When secondary systems with a good leaving group attached undergo Solvolysis reactions through the SN1 mechanism, a skeletal rearrangement is possible. In this example, a secondary bromide is going to form a secondary carbocation, which then rearranges. Since this reaction is at neutral pH, and there are no good nucleophiles present, this process will occur through the SN1 pathway, particularly in a polar protic solvent such as methanol. The leaving group is lost to form a secondary carbocation that is then able to rearrange. The strained 4-membered ring reorganizes to become 5-membered, and the carbocation is left on a tertiary carbon. Trapping of the carbocation then results in the formation of the rearranged ether product. Since this is an SN1 reaction, the first step will be rate determining, in which the polar protic solvent facilitates loss of the leaving group to give the 6-electron carbocation. With the leaving group still close by, attack to reform the starter material is likely, thus making this step reversible. Once the carbocation is formed, it then has the chance to undergo a fast intramolecular rearrangement to form a more stable intermediate. Migration of one of the beta bonds from the strained 4-membered ring places the charge on a less strained 5-membered ring, and also at a tertiary carbon that benefits from more extensive stabilization through hyperconjugation. Because the carbocation is flat, it is easy to attack, so a molecule of solvent acts as a nucleophile in a fast exothermic step to produce the protonated ether adduct. In this example, the carbocation happens to be prochiral, so a racemic mixture of adducts is formed. The last step in this process involves the alcohol solvent deprotonating the acidic oxonium species in a fast acid-base reaction to give the ether products. The polar protic alcohol solvent again plays multiple roles in this solvolysis process, from facilitating the leaving group breaking off to acting as the nucleophile and then reacting as a base in the final step. Overall, a solvolysis reaction on a secondary system such as an alkyl halide in a polar solvent such as an alcohol allows for the possibility of skeletal rearrangement. The solvent promotes loss of the leaving group to form the carbocation in the slow step, and then behaves as a nucleophile to give, ultimately, the ether substitution product.